Hello, and welcome to MVAO203, MainView Auto Operator Solutions and Integration. This is Part 2. MVAO203 is the sixth in an 8-part series of courses covering MainView Auto Operator. Auto Operator tracks exceptions through the use of an entity called alerts. Alerts can be generated in a few different ways. They can be generated from full-screen MainView products, including MainView for IMS, DB2, and CICS. In those instances, the exceptions are written to the BBI journal, where they can be picked up by AO rules and generate alerts or take other actions. Exceptions can also be generated from the Windows mode products, including MainView for ZOS, IMS, DB2, and CICS. Those exceptions are written via MainView Alarm Manager to the subsystem interface, where they can be picked up by AO to generate alerts or take other automated actions. Now I'd like to take a moment to talk about the background monitors in the BBI2 architecture. This includes the MainView for CICS, DB2, and IMS products. When these timers expire in the background and check to see if a threshold has been exceeded, the exceptions are generated to the BBI journal, where they can be picked up by Auto Operator and generate alerts. If you want to generate the alerts automatically, you certainly can by changing your params in BBI ISP and specify an alert queue on the target statement for the block member. Samples also can be timer driven, so you can say wake up every 10 seconds, check this value. If it exceeds a threshold, then an exception will be generated to the BBI journal, where it can be picked up by Auto Operator to take an action or generate an alert. If you want to create automation on these events, the event type would be journal, and you could take any of the standard actions you normally can with Auto Operator, including generating the alert, sending an email, issuing a command of some sort, or taking no action at all. In MainView for ZOS, we have a separate facility for creating background monitors called AEWS, and those samplers will execute continuously in the background and only produce a message when an exception is detected. In order to enable AEWS, you need to update the $IN sys0 member to specify AEW alert equals yes. For the majority of the MainView products, we can use a solution called MainView Alarm Manager to capture exceptions in the background and pass them to Auto Operator to generate alerts. MainView Alarm Manager is a feature of the MainView infrastructure that comes packaged as a component. It's not a separately charged feature. It does work with all of the MainView MVI-based products, which is the large majority of the products these days. And the way it operates is that when a metric exceeds a user-specified threshold, an alarm is generated, and that alarm can be passed to Auto Operator, which can turn it into an alert. When the metric no longer exceeds the threshold, the alarm will be automatically deleted. It will also pass an exception to Auto Operator indicating that the alarm is cleared. One of the advantages of MainView Alarm Manager is you can display all of your exceptions in a single pane of glass, and you also have the ability to generate console messages directly from the alarms. Now, alarms will automatically generate a corresponding alert, assuming you've enabled the 2 alarm rules to do that for you. Here you can see a list of the solutions that currently support MainView Alarm Manager. The list is relatively comprehensive and includes all of our window products on the mainframe. To access the Alerts and Alarms menu, you select Option E from the primary MainView menu. Option number 1 will show you the alerts that are outstanding for Auto Operator in a Windows mode display. And that's advantageous because that will allow us to do customization to the actual alerts display to make it more meaningful to a specific environment. We do allow the use of context, so you can have a consolidated alerts display through the entire enterprise as long as the CASs can talk to each other. If you want to do some administration of your alarms, you can do so from option 3 for the alarms option. After selecting option 3, here we will see the Easy Alarms menu, which we can use to view outstanding alarms as well as to create and administer existing alarms. On the left side of the menu are where you would do your alarm definition modifications, and over on the right you can view the outstanding alarms broken down and sorted by different areas, depending on what you want to see. Now I want to take a minute to cover some basic terminology related to Alarm Manager. An alarm is a message that's generated when a threshold is met or exceeded. An alarm definition is a set of conditions based on the MainView product view where the exception would be generated from Alarm Manager, and it's essentially the equivalent of an AO rule. It consists of a condition that you need to evaluate as true and then an action that you want to take. An alarm group is an arbitrary group of alarm definitions, and it's the equivalent of an AO rule set. The install command is used to put an alarm group or definition into the runtime environment in memory. So it's like enabling a rule or a rule set. It simply takes what you've created in an HFS and loads it into the address space so it can be processed. And then save copies the alarm definition into the library so it can be saved like a rule set would be. Let's step through the process of generating an alarm. It's really not a difficult process at all. So the first thing we're going to do is we go to the view where we want to detect the exception. In this case, I'm looking at a task view in MainView for CICS. What I'm going to do is I'm going to type make alarm, all one word on the command line, and then I'm going to position my cursor in the field that I want to set the exception on. So in this case, I want to generate an alarm when the suspend time breaches some type of threshold. So I'm going to put my cursor in the suspend time field and press enter. This is the resultant display I will see. So here we can specify a context and some other parameters. Typically you won't do anything on this screen except change the context, and you will do an N for next. And on this screen, we can specify the persistence for the alarm by indicating how many samples we want to evaluate and then how many must evaluate true in order for that condition to be evaluated as true and then take the subsequent action. In the middle of the screen, you can see the thresholds that were set in the view are inherited automatically to the alarm. So if you set your thresholds appropriately in the view before you generate the make alarm, then these values will be populated accordingly. On the report alarms display, you will typically take the defaults for all these values, but you can modify them. At the top, you say view equals yes or no, indicates whether we want to generate those exceptions to the alarms display. Typically, you'll always want to say yes. If you say WTO equals yes or no, yes means that it'll write the alarm exception to the console in addition to any other activity you may take. Now, WTO yes gives you a nice way to integrate Alarm Manager with non-AO implementations. And AO, he can see these directly, so there's no need to write them to the console and intercept them. And you can use variables to modify the messages, the start message or end message IDs, as well as the message task. And down at the bottom, there is a field for the hyperlink. You can modify this if you choose to. By default, the MainView Alarm Manager will take you back to the display where you did the make alarm if the condition occurs. If we scroll down on the report alarms display, there are some additional fields that may be of interest. There are the fields you can use to specify user values, which you can pass values to auto operator, or you can use them to customize your alarms display so it makes more sense to you. We can issue console commands from here. We can embed help dockets behind the alarms. If you want to generate an AO alert directly, you can do so here by specifying a user ID and queue. Okay, so there's a lot of different options available to you, but again, most of these you won't use on a regular basis. And the last screen we have is the alarm definition make. Here we specify administrative options such as which library we want it to go in, what the name of the alarm is, what group it is, and do we want to activate it when we exit. And here's an example of the alarms view, and you can see that our suspend time alarms are now active. Let's take a look at how Auto Operator represents the alerts in the Windows mode. So if we go to the Easy Alert menu, and we're going to select Ordered by Priority to display our alarms based on the highest priority first. And here's the result in Alerts Detailed Display. If we hyperlink on the field with the C in it, that will take us to the view where we did the generation of the exception. So it's a nice fast way to diagnose your problems a little bit quicker. If you link on the text of the alert, it will take you to more detail about the alert itself. If we select the help option for the alert, it will pop up a display similar to this. Now, some of these are delivered automatically with the product. Others you can build yourself and attach them to your own alerts so that they're more meaningful to your operations staff. It is possible to consolidate all of your alerts to a single display, and we can do so by using MainView customization. How we would do this is we would go to the alerts display we want to start with, and then we type in customize or cust on the command line. When we're in the customization dialog, we can move fields around. So if I scroll over to the right, I'll see that there's a target field, and I can move that over to the left so it's visible in the default part of the view. Once I do that, I can save it as a new view. You can call it whatever name you like. That becomes a command to take you directly to that display. Once I give it a name, then I need to go into my user ID high level BBVDEF, and I copy the member name that I called it into the SBBVDEF. And the reason you do that is so that the other users in your shop have access to that same view. Now you can hide fields, you can include additional fields, you can do whatever you want in view customization that makes the view more meaningful to you and your coworkers. Once you've built your view and you've saved it, you can do a context all, which will show you the alerts from all of your systems consolidated to a single display. And then you can save the screen as alerts or anything else you want to call it, and it will preserve it with a context of all. So when you come back into the alerts view that you've created, it will have everything all set up and ready to go for you. As I mentioned earlier, AO can trap MainView alarms. In order for this to work, Auto Operator must be on the same manager as MainView Alarm Manager because the messages go to the MVS subsystem like WTOs. There's no connections that need to be defined or passed via the subsystem interface. Alarm events do come up with a few unique variables. There's an IMF ALID, which passes the alarm ID. AMF AL PRI is the priority of the alarm, and IMF ALQID is the name of the queue to which the alarm was assigned. Now, if you want to replace these rules, you can do so by specifying alert receive yes and BBI SSP00 of the UBB parm assigned to the auto operator. This concludes MVAO 302